you see these crosses. These crosses are the electric lines of field. So there is an electric field according to the question. So I will show you how this field is generated. Now you can see there are two plates. One plate is connected with the positive terminal of the battery. This one plate is connected with the negative terminal of the battery. So this red color plate is charged positively, this blue color plate is charged negatively. So there will be a electric field like this. But this electric field doesn't penetrate this plate, so I will delete this plate. Therefore I will delete this plate also. I will delete these batteries and wires. So the electric field is now like this. In the question you see from this view, the diagram is drawn from this view. So only the crosses you can see in this region 1. So this is the electric flux. The direction is into the paper. You see the arrows, these are the arrows. So in the question the diagram is drawn like this. So what happens then? An electron enters this region. So this is the electron. So having a negative charge, this electron enters this region. So I want those plates again to limit the region. Therefore I get them back, those two plates. With those plates it is easier to show. So this is the region. So what happens? They say an electron moves along a straight line like this across this area. It goes like this. But it can't happen regarding this electric field, because this plate is charged positively. So this electron has a negative charge. So it must turn or deflect to this plate as soon as it entered this region. But in the question they say that this electron doesn't deflect to any side, it just passes this area along a straight line like this. So how that happened? Since there is a force towards this side, this direction, so I will delete this electric field. Now I will I will show you the force lines. So these are the force lines, because the electron is attracted by this positively charged plate. So these are the force lines, electric force. Electric force act this way. So you see the arrows towards us out of the paper. So this black arrows denotes electric force lines. Earlier we had electric flux lines. So you know, electron moves against the flux lines, against the direction of electric flux. So that is why I have turned these arrows out of the paper. The paper is this red color one, the red color plate. The paper is this red color plate. So the arrows now direct to out of the paper, direct to out of the paper. The flux flux directed into the paper, but this arrows direct like this out of the paper. So this is the force now, this electron experience. So therefore, when this electron enters this region, it must bend to or deflect. It must move like this. From here it comes and it must fall into this plate. But in the question they say not such a motion is happened. What happens is it just passes this region along a straight line like this. So that means this electron doesn't experience this electric force. How that happen? How can that happen? Then there must be another invisible force which cancels this electric force. So that invisible force must be that magnetic force, because in the question they say there is a magnetic field. So cancelling this electric force, there must be a magnetic force opposite to this electric field. So now I will show you the force lines of the so-called magnetic field. So magnetic force, this one is the magnetic force. These arrows are magnetic force lines, because it must be opposite to the electric force lines. These green color arrows are not magnetic field lines, they are force lines, because we know the invisible force must be against this black color electric force, must be against. So now we can draw magnetic force lines must be like this. So this is the magnetic force. So each other cancel, and the electron can now move without any effect from these force lines, either from electric force or either from magnetic force, because they are opposite to each other, and from the quantity, the values are same. So now we know these magnetic force lines are present here like this. So I will remove this, we don't want this now. We know now the magnetic force is here like this. These are the magnetic force lines. So you have to use now the left hand rule to find out the direction of magnetic flux. Now we need our left hand. So you know how to point your fingers when you apply left hand rule. So this picture is our left hand. So you know the force is the magnetic force is denotes in this green color arrows. So you have to turn your thumb of the left hand to that direction. So like this, to that direction, the thumb you have to point out. So the center finger current, since the electron comes from left to right, so this way, since the electron come from this way, the current is opposite. So this one, this direction is the direction of current. So therefore you have to turn your middle finger to that direction, thumb to this direction, to the direction of green color arrows. Thumb to the direction of green color arrows, because green color arrows are the magnetic force lines. So since the electron comes from left to right, you have to turn your mid finger to the direction of right to left, because the current is that way, right to left. So like this. So the index finger denotes the direction of magnetic field now. So you see the magnetic field is upwards, magnetic field is upward. So therefore we can now go to the other picture. So magnetic flux is like this now. Magnetic flux is like this now, to this direction up. The arrow is upward. So finally we know the magnetic flux lines, the magnetic flux is upwards. So in the question we can choose that answer. Therefore the answers, this 2 and 1 are correct for region 1. Now let us try to decide the direction of magnetic field in this region 2. In this region 2, no electric field is applied. The only force is magnetic force. So you can see this electron moves along a circular path. We know in mechanics, if any object moves in a circular path, there must be a force to the direction of center, direction of the center of the path. That is called centripetal force. So since this region 2 has a magnetic field, the force must be magnetic force, because the only force it has is magnetic force, magnetic field and magnetic force. So this force must be, then magnetic force must be to the center of this circle. So the electron moves this way, so the current is opposite to that. So the direction of current is this way, I. Now you have to again use your left hand like this, thumb to the magnetic direction of magnetic force, this way, force, then center finger to the middle finger to the direction of current, I. Then from index finger you can get the direction of magnetic flux density B. So it is a pointer, it is the, so it is out of this paper, because fingertip we can see, so it is a dot, it is a dot out of the paper. B is out of the paper. This arrow is wrong. The arrow point we can see like this, that is the dot, because out of the paper this finger is pointing out. So then this one is the answer. Earlier both of these we selected, so now this second one is the answer for this question. So thank you very much for watching my videos. See you soon. Goodbye.